Okay, Assalamualaikum warahmatullahi wabarakatuh. This is our last subtopic in chapter 4, 4.7, don't care term on kind of math. So, um, some logic circuits may be designed so that there are certain input condition for which there are no specific output levels. Okay, so usually because this input condition will never occur, so we don't know what happened on that current input. Okay, so in other words, there will be certain combination of input where we don't care whether the output is 1 or 0. Okay, so let us consider this. Let us consider a logic circuit that will detect an odd number from a BCD code. So we know that BCD codes are number from 0 to 7. Remember? Okay, binary coded decimal. So the number is from 0 to 9 only. So, but we need 4 input because 9 is equal to 1001. So we have 4 input A, B, C and D. Okay, 6 numbers are not used by the code, which are start from 10 to 15. Start from 1010 until 1111 because it is not included in the BCD number. So this combination are called don't care terms, meaning that we don't care, okay, about 10 for 10 to 15. Okay, so suppose the output y equal to 1 if the input is an odd number. Why? Because this circuit will detect an odd number from BCD code. Okay, so when the number is odd number, so the output is equal to 1. Okay, other than that, it will be 0. So from 10 to 15, it will be don't care. Okay, so there are 6 don't care term which is labeled as X. Okay, X. So 1 is odd number, 3 odd number, 5 odd number, 7 odd number and 9 is also odd number. So 0, 2, 4, 6, 8 is the output will be 0 because it is not the odd number. Okay, so now we will extract this information from output table into this KMAP. Alright, so we have 4 input, that's why we have 16 cell. Okay, that's why we have 16 cell. So let's input this one first. Start with 1 0 0 0 1 1 0 0 1 1 1 0 1 0 1 0 1. Okay, 0 1 1 1. And then 1 0 0 1 here. Okay, so don't care, we have start from 1 0 1 0 until 1 1 1 1. So 1 0 1 0 1 0 is here. Okay, and also here, and we have from here to here, here and here. Okay, so how to use this don't care? Okay, and X on the K map means that the cell can be 0 or 1. Okay, it can be 0 or 1. So cell containing ones can be grouped together with cell containing X to form a bigger loop. Okay, remember we want to have a bigger loop. Why? Because we want to have a simplified equation. Okay, so in this example, okay, so X can be used to be looped with loop containing A to get a bigger loop. So in this case, if we left this X, okay, if we left X out, so we only have a loop with 4 containing 4 ones. But if we take this don't care, we can have a bigger loop which containing 8 ones. Okay, containing 8 ones. So the simplified equation is y equal to a bar or a bar, a bar, a or a bar or a 1, B bar B or B1, B or B bar 1. So C bar or C1, D or D. So the answer is D. What about the rest? Okay, sorry, I forgot to fill in with 0. So what about the rest? What about this X? What about this X? What about this X? Leave it. Okay, we don't need it. We just need the X, the don't care term, when we want to have a bigger loop that containing 1. Alright, so Y equal to D. So how to draw this? We have one input only, right? So D, Y. This is how to draw the logic circuit. Very simple. So we have done chapter 4. We start with what is K-map, the introduction of K-map, and then what is the function for K-map to get a simplified equation. So there are two methods to get a simplified equation. The first one by using Boolean algebra theorem, already learned it in chapter 3, and the second method is by using Carnot map. So basically this is the easiest one. Alright, but in the question, please follow the question. If the question asks you to get the simplified equation by using K-map, then use K-map. If the question asks you to use Boolean algebra theorem, use Boolean algebra theorem. But in the question, they will state it. Will state that. Okay. Usually for part A, okay, for part A, they will ask you to get the simplified equation by using Boolean algebra theorem. Okay, don't worry because in the question they will state very specific what you are going to use. All right, and then we move to 3 input K-map, 4 input K-map, how to get the simplified equation, how to extract the information from the truth table into the K-map, and how to loop, how to get the simplified equation. And then we continue with draw the combinational logic circuit. All right, okay, there are 3 steps. The first one is derive truth table. The second one, get the simplified equation in this chapter 4. So we use K-map to get the simplified equation. And then we draw the logic circuit. And last part is the don't care term on Carnot map. Alright? So I do really hope that you understand about this topic, this chapter 4, Carnot map. And we will do some exercises to get to know that either you understand or not. Okay? On how to use this K-map. So thank you so much. Assalamualaikum warahmatullahi